actually get started. Going to upload it later, so for other people to watch. Okay, welcome to another episode. I think welcome Connor here, and also our regular guest Kevin. Connor, like I think you have been, tinkering with sCrypt for the past week or so. How's your experience so far? And if you don't mind, can you share with us what kind of things you are trying to achieve with? I think mostly you're tinkering with PushTX, right?
Yeah, I'm not ready like completely to share everything that what we're doing, but I guess the reason why I was digging in sCrypt you had mentioned was the outpush TX stuff, which I'd obviously read. I think you published that article in like 2020 talking about it, and then I just saw the other day, I guess, the history of. I didn't actually realize the history of how it became public either, so that was interesting too. But I was just trying to dig in more on outpush TX because obviously the ability to examine the current transaction is really valuable. And so in order to do that, I feel like I just had to look into sCrypt a bit more, and I quite enjoy it. But I admit I was a little confused at first because I was so used to the Bitcoin script way of thinking about things, where it's kind of like a locking script, unlocking script, and then I had to think about that in terms of a contract was what confused me at first. But then once I figured that out, it's quite great to use. So, but I know you already know that, so that's it.
Okay. Yeah, I think that's one of the, if not the most difficult like a concept. Usually people come into sCrypt. It's so widely used, but it's at the beginning it's not easy to grasp. To be honest, even for me, I think when I first get it working, I think even for me I have to kind of like internalize it because it doesn't feel intuitive. It's kind of like a magic, but then once you go through, make the code works, then you are saying, oh, okay. Then it's because if you push the right preimage, everything checks. But if you push anything, like if you have one bit different, it will fail. So
one of the things that really helps me with the like wrapping my head around it was on that web IDE that you have, where you can see the it like compiles it into Bitcoin scripts, and then you can see it go on the stack. It's like a visual thing. Do you know what I'm talking about, Chowei?
Yeah, Studio, sCrypt Studio.
Yeah, sCrypt Studio. Yeah, that was super helpful. But some of the more advanced features is where I get stuck right now. But again, like I said before the call, I'm working on like so many different projects. This is like 10% of the puzzle that I'm trying to solve is the sCrypt, and I view it as programmable money. Is so that's why
I would be interested in helping if it is helpful. But I think what would be helpful for me is when I look at something in sCrypt, and then when it compiles, it would be really awesome to like even just with an article. I'd be interested in helping with this if you want. But I guess like it'd be really interesting. You have the outpush TX contract, but then to be able to like once it compiles to script, explain where the match is between what was happening in the compiler to what actually gets spit out. You know what I mean?
Okay.
Just because I don't know. I think I actually find it easier to think in terms of Bitcoin script in some ways than I do thinking about it in terms of a contract. But that might just be me. But I don't know. I'd be happy to help even just with an article or something for each contract, trying to explain what's happening in the script, because I don't know if I'm the only one that's like that, but to me it's easier to think of it in terms of locking and unlocking scripts. But
have you seen the Visual Studio thing, or not? Sorry, not the Visual Studio, the sCrypt Studio web thing, Connor?
Oh yeah, I've been using it way too much.
So, oh, you have? Yeah. Okay, cool. Yeah. I was gonna suggest that Chowei pull it up so I could, but I'm not at my computer. I'm at my iPad. So
yeah, I can pull it up. I've the funny thing is, originally when I deployed, I thought that most people will use it for sCrypt, but for whatever reason, good or not, a lot of people are just using for raw script. So.
Oh, I see. Yeah, but like this is.
Yeah, they just come here. Yeah.
And then you can type these in, and then on the right side, you could see it in the main stack and the alt stack, and you could step through it really easily. So this is where I had to start. And then what you can do is write these codes on the top, but then it compiles into these locking and unlocking scripts. So yeah, this is super, super helpful.
Xiaowei, do you have your own interpreter, or is this running, like what interpreter is this running? Is it running a sCrypt local interpreter?
Oh yeah, just the multi-pattern BSV. We use that interpreter. Yeah, internally.
Because I think there's also learnonchain.com/script, but I think they also use the BSV library interpreter. But I know that some of, I don't think all the opcodes work in the BSV interpreter. So it'd be good. So we've been working on the Golang interpreter from bScript that I think Jad and his team have. I'm just trying to get them all updated, but I actually don't have like a list of the ones that aren't working or not. But I know that we're working on that. I know Brendan Lee was interested in working on that too, but it'd be good to see, like, for example, I don't think op bin to num or op num to bin work with the interpreter. I don't know how they handle that or how they.
Oh, you mean Golang version, right? This one works. The Java,
okay. Yeah, okay. Yeah.
Yeah, JavaScript works. The Golang we had, I think mostly work because we also have a Go SDK. So we have some minor issues. I think it's not. Yeah, I think one of them. I think it's maybe it's number to bin or bin to number. I forget. Yeah, it's not battle tested because most people who are using this kind of like a non-standard script is coming from sCrypt, and we are I think one of the few that actually play with script daily. So it's just not, a lot of people have used the library for the interpreter. So far it's not well tested. I think we report a few issues to Jed. I think he is aware of them, and he's trying to help us to fix. But this one, yeah, this one works. Yeah.
If you know of any of those issues, let me know. We can, because we might be able to help with them too. Although I think my brother spent all weekend like getting an interpreter working and then found Jad's interpreter. So he was pretty upset.
Okay.
So, but
yeah, we are using it. I think we submit some I think issues to them. I forget I'm going to share the GitHub link. I don't have it now, but we submit a few issues there. One of them is it's not opcode. Basically, if you know for a script to be, before you interpret it, the Golang version actually, try to parse it first. So not like a JavaScript, right? JavaScript is kind of like a truly interpreter. You just interpret it on the go. It doesn't check, do processing. But Go one is to check whether the syntax is legit. But here's the problem: if some syntax is invalid, but it's after op return, that's fine.
Right.
No, whether the change in Genesis or something, but we have something op return, right? Put it in a state that's absolute data, but they interpret it as like valid. So that give us some problem because if they just pre-process it, it will fail immediately. It doesn't even run it, but that's like a false positive, right? So that's one of the issues. Yeah.
Yeah, that makes a lot of sense.
And to get back to the push TX, I think for us, we haven't put out that detailed explanation out is here's the thing, right? So most people, the reason you and me, we do this kind of low level stuff, so they don't have to understand, right? Unless they're doing some kind of like I don't know, like SDKs for script or sCrypt in some other new language or some kind of like a low level library. For user, they just use it. They don't have to understand. That's the whole point, right? If they want to understand it, yeah, they can use. I think I sent you one article about basically some guy like he called French Frog. Basically, he's actually our intern from France. So he detected this 1 in 65K chance of the output failure, push TX there. For that, he just used our premium IDE because for us, we can also I think the Studio is good, the learn chain is good, but it's still primitive. But if you want to automate the experience, the most professional one it's still going to be our sCrypt ID, the desktop Visual Studio plugin. So if you use that, then you can watch all the, in details. That's how he steps through the opcode and then map it to the pretty much the ECDSA assigning algorithm, almost line by line. So you can go through that. That's a way to, if you really want to get into details. That's an ultimate approach. Yeah, I think I may want to publish some video just to show the mapping, because it does show the mapping if you ever use the script level debugger.
Yeah, I've seen that, but I guess I mean it tells you what it's doing as it goes along, but maybe like the why isn't. Which again, I understand that you don't necessarily need to give the why if it does what it does, right? But maybe just my curiosity is what gets the better of me there. The other thing that I guess I'm curious about, but and I'm sorry, I don't want to take this over, so I'm just asking questions.
No problem. I mean,
totally fine.
So how does sCrypt determine, for example, if something needs to be duplicated, sometimes I feel like the contract will compile and it will do op0, op-pick instead of op-dupe, or like how are those decisions made by the compiler, or is it just, obviously it's going to happen with any compiler, it's going to make arbitrary decisions, but
you mean specifically why use op0, op-pick instead of op-dupe? Is that what you're saying?
Yeah. In some, when some contracts compile, it just seems to arbitrarily pick op0, op-pick as opposed to op-dupe.
Oh, here's the thing. So if it's not optimized, it can happen op0, op-pick, right? Can be there because it's a general thing, right? It's trying to pick some variable. Let's say A and B, but A is on top, at the top. So it says, oh, I always pick, right? If it's top, I just pick the offset. But if A happens to be at the bottom, the top, it will be 0, right? But if you try to pick B, the second to the top, it will use op1. But here's the thing, right? If you supposedly, when you compile, you can choose a debug mode or the release mode. Release mode will optimize it. Hopefully, I think there will be if you op0, op-pick, it will be translated to op-dupe to save 1 byte.
Interesting. Cool. Okay. No, that's awesome.
And then eventually you'll have like an optimized version, right? Wasn't that your payment model where similar?
Yes, we have the premium version. Yes, you can try it. Yeah, I think.
But is there a difference between debug mode and release mode?
Yeah, debug mode. Number one difference is there's no optimization. You just get it's working, but it will not be the smallest.
But I guess my question is the release mode your premium whatever?
Yes.
Okay, so you only get the release mode if you have the premium version.
Yes.
Okay, got it. And I got that a while back. I just didn't realize I just had them both.
Yeah, when you right click compile, there are 2 options, right? You have debug, you have release, like most other languages.
Nice. No, that's awesome. I didn't realize that. Sorry. I think I need the premium. I think I asked you to pay for it a while back. I never did. So.
Oh, okay. Yeah, if you need one,
I'll get on that.
DM me your payment. No. Payment I will just give you. That's fine. Okay. So when you are trying to understand the push text, is that like because you spend, even for you like experience, you spend quite some days. What aspect do you think that can improve, that can help newcomers to understand it faster? What are your mental blocks? You're like, before that, you're like, this is kind of a black box, and then there's some eureka moment, or is all gradual?
Sure. Okay. So I guess I'll explain. Generally, we've been trying to create a solution for like a self-validating metanet structure, right? And I'm pretty sure we have it figured out. And I'm pretty sure, I don't want to get ahead of myself, but we are working on a solution to the back to Genesis problem. And I think we have a path to do it. I'm not ready to like say we do it for sure, but I have a plan and I'm exploring it. But I guess obviously op-push-tx is going to have to be required for that, because you need some way of creating some kind of validating structure across the transactions. And in order to do that, you need to examine some conditions about the current transaction, right? So that's kind of the general process that we're going through. I don't think, as the MetaNet protocol exists today, I don't think you can create a self-validating MetaNet structure, because
It's one parent, multiple children, right? So if it's UTXO, you can only spend, you cannot double spend, right? That's my short answer. But I don't know if there's any way to get around it, but that's my understanding, right? If you have, maybe you can do it at transaction level, because then maybe you can have multiple outputs, then you can each spend. Maybe, yeah.
I guess I'm curious why that would. So as of right now, the spec is just publicly, in order to create a child, you have the public key of the child and then the transaction ID of the parent, right? So if you wanted to have something that was self-validating, you can have the public key of the child quite easily validated, because if you insert pay to public key hash, then the public key has to be into the, you can validate that that's what's signing anyway, right? But what definitely can't be done is the transaction ID, and this is kind of what I think Attila talks about, is there's no way to reference that transaction ID. For example, in the pre-image, you might have the transaction ID of the input, but I can't link that to the next locking script, right? So in the next locking script is where I define that parent transaction ID. So that can't be done. But I guess I don't see why multiple children would matter here, because as long as there's enough, if these MetaNet nodes were spendable, then as long as there's enough Satoshis in the parent node to cover, there's a finite amount of children you could create, but maybe I'm missing something why the multiple children would defeat that.
Oh, I thought at the beginning, I thought it was each children is like a specific UTXO. It's a transaction at the UTXO level. Because if it's at UTXO, you can only have at most one child spending, right? You can, otherwise a double spend.
But the node isn't defined by the UTXO. The node is defined by the public key. So as long as the public key,
okay,
has enough to cover however many children.
Okay. Then that's possible. Okay.
But as the spec exists right now, there's no way when I define the node as public key X transaction ID parent, then there's no way for me when I spend it to validate that the new locking script has the transaction ID of the input without doing some layer on top that does that validation. But you know what I mean?
Why not just use pushDX to forward the transaction ID into the output of the new transaction? I think we do that a lot, right? Even if you look at the peer-to-peer token article, we do that to have a global unique ID.
Okay, but okay, I need to look at that, I guess. But how would you ever validate that the like there's nothing in script that's going to be able to validate that transaction ID is linked, can you? I mean,
oh, no, that's again, that's
right.
the problem we talked about last time, and I'm glad
Right.
you're also trying to attack it, because I know like at least five people or teams trying to attack this problem, which is huge. I think it can be solved. That would be like, I'll be like, that would be like the day I discover pushDX. That would be huge. It will be as big, if not bigger. Yeah.
I think it can be done, but I could be wrong. And I probably will be wrong, but I think.
I hope you are right, really. I hope anybody will be right. Attila, I think, Shatters, he's in here some way. And also Brandon, he said he may have some way, but I've not seen anything yet. So, okay, I will trust, but I want to verify. Yeah. So.
Yes. Yeah. Me too. That's why I'm not saying.
Yeah, don't disclose it. Yeah, make sure it's good. File some patents or something first.
Yeah. I'm sure it's covered, maybe. But anyway, yeah. Sorry, I'm just a newcomer here, so I just wanted to let you know. But I will say the sCrypt, obviously, it's great. It's just
okay. Yeah, for me, we mostly want to, for people who have using sCrypt, if you have any questions, because sometimes it's kind of hard to, type in text or read articles. It's good to have interactive talk, because, it's just it's much easier to explain. So that's why I'm coming back. So, okay, so when you try to understand push text, so anything particular you find difficult, or is almost like it's just gradual. Then as you play with, you just suddenly you just understand it. There's no. I'm trying to see if there's any way I can improve people, so can
Yeah.
uh,
Well, so if I could explain how I approached it, maybe that would help you. Now, I was approaching it I was already building scripts just directly with sCrypt, so not with sCrypt. So then I knew that I wanted with my script to add push tx here, but I didn't know how to do that. So I went into sCrypt, compiled the contract, the optimized contract, and that's when I think I came to you and I was like, why is there this value here? Why is this their value? There was no explanation anywhere I could find that was like, the optimized script spits this out, and here's why it spits this out, right? Obviously, if I was building all this in sCrypt, I wouldn't need to know that, but I was, so it spits out op0, op pick, and so then I had to make the guess that it's probably picking the pre-image, because otherwise, what else would it be doing the double SHA-256 hash on? So then it hashes that, and then I didn't understand, it picks the first byte, I think, of the hash, if I'm not misremembering this, adds 1 to it, and then concatenates it back in, and then it pushes the R value. But then my question was, is the R value getting calculated somewhere that I don't know about, or is it? And then you told me the optimized script is generated using, K value of 1, right? So that was, I guess, my mental progression of asking questions. Of I knew I had my script, and I knew I wanted to insert push tx here to get the pre-image, but I didn't know. So then I went to sCrypt, pushed out. I didn't want to get a large script, so I wanted a smaller script. So I pushed out the optimized script, and then it was, I don't know why this script is doing what it's doing, and I don't know where this R value in public key are coming from. But then obviously you answered that for me. So
okay.
That was my logical progression, if that's helpful at all. Yeah.
Okay. Yeah, you're like a little bit special because you kind of jump through the non-optimized version, because that's what most, I would say, you are the only person I know who just skip that and just directly go to the optimal version. Because most people, they have to look at the first one. It's much longer. I think it's 700 like bytes, and this one is like I don't know, like a 90 bytes or something. Yeah.
The lazy part of me was just I want to keep my script as small as possible.
Yeah. The only downside is you have to almost like half the time you have to manage your transaction to get to the kind of low S, which kind of hassle, but you can do it. It's just a lot of people just forget it, so they will fail. The check sig does not pass.
Well, and that's why I think, I think just having libraries out for this stuff is just benefit. So that's what we're trying to do. Just like if we have a push TX library out there that, it's well commented, well explained of, now that you have your pre-image, run this function to get low S out of it, right? I think that'll help people, but I don't know. I mean, that's where I'm just I come from the fact of, obviously what you're doing is making everything way 100 times easier, but I feel like there's still just so much to do in terms of the people actually building stuff of, helping other people get into this stuff and figure it out. Because but that's what we've been doing for years. So I guess we're just gonna keep plugging away. I don't know.
Okay.
I think one of the,
yeah. So,
yeah.
Sorry.
I was gonna say one of the ways to learn how people are getting stuck is by watching them actually do it. Because I used to work at the Apple Store, and we'd like teach people how to use the computer, and we'd sit there and we'd watch them try and navigate. And instead of, I remember one of the things they said is, don't push the buttons for the customer, let them push it. So if you say, go to settings and then go to software update and press update, instead of just doing it on their phone real quick, you have to watch them do it, and they'll sit there and they'll struggle, and then they finally get it, but then it's in their muscle memory. So if you're trying to understand where people get stuck, because a lot of times it's not even conscious. I don't even know where I'm stuck, and so I can't articulate it. But if you're to watch me try and compile a contract, you'd see that I probably, get I do different things or have a different workflow that's different or something like that.
I would say my biggest struggle too, and I'm sure this is everyone's biggest struggle, but I don't want to look stupid either. And I think that's probably everyone. So, but I've learned you have to get over that, right? If I'm just like, hey, Shawway, this isn't working, and he's like, yeah, you missed this obvious sentence I put in this article, then that's, you know, something you kind of get over and just
Yeah,
do it.
that's always that's why they said the devil is always in the details. So for this trick, it's like everything has to match. It's like you have at least 10 things, right? It's like a checklist from 0 to 9. It all has to check. If you have anything that's missing, that's the beauty of it. You cannot make a. That's good because then you cannot cheat, right? If you
Right.
not push the right push pre-image, you're definitely going to fail, unless you have some like a hash collision. But we don't worry about it.
Yeah. I think like along what Kevin just said, I think it's probably the best point is that it's all so new, and then I just think probably it would be really beneficial for people just to get out of their comfort zone and ask questions, because Shawway, you don't bite, I've found, so that's helpful.
Mhm. That's no silly question. I'm saying that's why the Slack is for. So I'm glad that people are like I think it's becoming more and more active. So a lot of people are chatting there. I think especially for the back to the Genesis. Yeah, it's like somehow it's I think since the last meetup video is again gaining traction again, because this is almost like a, yeah, I call it a holy grail. But it is kind of holy grail, because if you can solve this, it's like you go to another level. You don't have to rely on a backend. A lot of things you can just do it. If the miners verified, it's good. So just much easier.
And I do wonder, so along the back to Genesis problem, the thing that I've been thinking through, I wonder if, you know, there might be a function of good enough when it comes to back to Genesis. So for example, if you could validate that everything outside of the UTXO set is good, but you may need to do some other validation on, you know, chain transactions in the UTXO set, then that's pretty good, right? So I do wonder if the back to Genesis problem has an economic solution to it that's outside of
I see. Yeah, at least I know of two groups. I think one is Jeremy from Dr. Wally, and the other Attila. They try to use similar idea for the you just mentioned, for specific case. Let's say NFT, but maybe for a house, for a car, for some paintings, which don't exchange hand, don't get transferred frequently, right? So maybe your car or house. I don't know how often you buy a house, but probably not every month or every day, right? So then you can just send the whole transaction, the chain of transaction back to the other way to the Genesis, right? And then maybe you're like, there's only 10 transactions, or maybe the house get sold for like 1,000 times, but then it's still 1,000 transactions, which is tiny, right? In terms of today's bandwidth. So they can use that for kind of a lower frequency NFTs. It's more than good enough, right? Because I just send you the whole history. Maybe even that is like it's almost like when you buy the car, you have the, you know, all the history. That's like a part of the car, if you can think about it. So
right.
And it's doable today, right? You don't need like back to the Genesis. You can just verify it off chain. I can just do all the transactions.
Sorry, I think I misspoke because I said the UTXO, but you're right. So anything unconfirmed, right? Anything not in a block is maybe where the validation would have to occur. And maybe you could build something that once the script is in a block, you have some confidence that it's accurate, right? So I don't know. I'd be curious. I think there's. We'll see.
Yeah, I think I've been seeing multiple people saying they're going to publish something in the next couple of months, but yeah, it'll be interesting to see. Yeah, hopefully, but
when we were talking about the car stuff, you got me thinking about that. Like, where is that? Because I know when I go to the dealer and I get my car maintained, there'll be like this thing where it's like the record of all the maintenance. But who has that? Do you know what I mean? Like, who's
the title, right? The DMV has the government have the
is it
title, right? You when you change title, they have the record.
Well, I know they have
like they just give you the whole whole history of all the owners, the previous owners to you. When you try to sell somebody your car, you just give all the history to them. They can verify.
Yeah,
It's not in
I
script.
know it.
Yeah, they can.
Well, I know that I register the car with the DMV, but I'm talking about there's this other database. I'll have to do some investigation, but it's like, the history of maintenance, and it must be that every car auto shop maintainer or whatever, they must all plug into the same database, but I'm wondering who owns that database. It's like, tires changed, oil changed, cabin air filter changed. There's like a record of, accidents and replaced parts. So it's kind of interesting, but that you got me thinking about that with what you're saying.
I have a hunch that some states maintain that database, but I guess the point is here, I mean, so probably the interesting part here is that depending on the transaction frequency of what it is would determine how much you need to solve this problem, right? So that is interesting, because if I'm, like you said, buying a house or buying a car, then if the cost of having the whole record of ownership tied into the transfer, is less than a fraction of a percent of the value of the car, then it probably doesn't matter that much. And it's probably cheaper than all the other maintenance, like you're saying, of keeping all those records, right? So it's interesting. It's probably,
it's only a problem if it's got like a high frequency change of hands. It's like the token in theory, right? You can change like hands like 1 million times, right? Usually it's not a good idea to just, if I receive this thing, if I want to verify, you send me like another 1 million other transactions. It's only a problem for that kind of scenario. So,
but the reality of it too is for us, for anybody, but if we're building like a data structure on Bitcoin, and that data structure is going to be updated multiple times, then no matter what, this has to get solved. If the data structure is a DAG like the MetaNet spec is, then the data structure is high frequency trading no matter what, right? So it does need to get solved no matter what.
It doesn't have to. It's like you solve this, you solve all the cases, but if you don't, it's somehow, I would say it's still big use cases, but you don't have frequent thing. It's still good enough. Same, I think probably same applies to MetaNet, because if the tree, I don't know why people call it that. It's a tree, right? Just in my mind, it's a tree, right? You don't have circles. Anyway, if you have this stack or tree, it doesn't get updated often. You can still just give me the whole tree, right? If it's like empty, it's a painting, Mona Lisa doesn't change hands, maybe a few hundred years or something, you can just give me the whole thing. But only a problem, right? People like a trade. People are doing trading, all kinds of trading, back and forth. Then it can be a problem. But even 1,000 transactions is not big. Seriously, it's not big.
Right. But if the tree too, the other problem too is that if the tree has multiple owners in it, right? So maybe you have a data structure, but the ownership is, you can imagine like a Twitter, where there is some tree where everything loops back to one root create Twitter function or whatever. Then if there's 1 million users down here that are still descendants of that tree, then everything that they do under their tree is high frequency and whatever else, right? So and maybe they're sending something from one owner to another. But yeah, you're right. Any general use case will have to solve it anyway.
So I'm actually now starting to understand, I think, the problem that we're talking about, the back to Genesis problem, better. Now that we just talked about this. And I remember you in a Bitcoin class with Satoshi were talking about the DAGs, and I looked that up, and I understand what you mean, where it's like a tree. It only goes one way, it doesn't come back. So if I'm understanding your problem correctly, that we talked about last class, it's that you can have this thing that has just like huge amounts of branches. Is that right?
Yeah, it's the depth of the tree is like 1 minute. Let's say.
Yeah. Okay. So yeah, the depth. So the depth of the tree is so big that you can't just give the tree to somebody to prove the entire ownership, but instead you just want to be able to verify in a quick way that's, you know, faster than, I think, linear is what you're talking about or something. I forget those exact terms. I remember in computer science we did like O of n or something, and
Yeah.
linear.
Yeah, if you talk about complexity, you want to make sure if the minus checks it is good, then it's good. That's like a kind of like holy grail, right? Then you don't have to go back all the way. You like then you can do SPV, right? I just give you check, it's good, and then it's good.
Okay, and then
to send the whole path, right, from the root to all the way to the leaf.
right. Okay, and so you're worried, and then so you pulled up last time. There's like these few different attack vectors, and one of them was a man in the middle attack or something with a red box, and then what was the other one? But I'm trying to understand how can it get where is the spoofing actually going on that we're trying to prevent?
Well, so I mean, it probably depends on the different protocol, but if we take the MetaNet protocol as an example, then you have a public key that's defined as the node, and then you have the transaction ID of the parent node that's attached to it. That's what defines the node is both of those two things. So that means that if I want to validate that this node is a child of that node, I need to check that that node actually came from transaction ID parent, right? But since there's no way to do that in script, that means I have to have something else that runs on top that says pull out the transaction ID of the parent and check that the input for that node came from this transaction ID. Whereas theoretically, I could insert, you know, public key node transaction ID parent, that's wrong. And then if something else was just looking on the outside and it said, well, that's defining this transaction ID as its parent, that may not actually be the parent of the node, but it's just going to say it is. And then, you know, if I was doing validation, then I would insert that node somewhere that it shouldn't be, right? That's how it would be relevant for something like that. But there's obviously 8,000 other token protocols that it's probably relevant to too.
Yeah, it's not only limited to token. Yeah, as Connor said, right? So MetaNet probably has a similar, if not exactly the same problem.
Yeah, well, I was thinking it reminded me of, because I am like super interested in fruit trees, and one of the things that you can do is you could splice, so, or it's called grafting. So you could actually take a branch off of one tree and put it on another, and it's going to yield a different fruit. Have you guys, do you know about that?
Yeah, it is similar how the attacker is going to attack, right? So
yeah, exactly. That's exactly right.
Okay.
they create a fake branch. You cannot until you trace all the way back, because they can always.
But I'm wondering if there's a lesson to be learned from that by, you know, exploring that process of, then you could solve it for computer science. And because it looks pretty similar, but it's going to yield a different, it's going to have different genetics and it's going to yield a different fruit. I don't know exactly how that happens, but maybe I'm trying to use the metaphor that's not possible, but I'm just fascinated how that process works. I don't really know how it works in biology.
I think that's an interesting idea. Yeah, I think that there could be something there.
Because you literally just, I'll send a video on the link, but you just cut off a branch and then you put it on, and then the tree kind of picks it up and it keeps on going. But that, all the descendants of that branch are going to yield a different fruit than the core of the tree.
See, because Xiaowei, do you not think that it would be accurate that if you inserted the MetaNet protocol, that simple protocol of just public key transaction, if you had a way of validating that those things were always true in script, you could attach that to any other token protocol or to any other, as long as the token protocol was sending things between public keys, then that would be a solution. If you could attach that to any other existing tokenization solution, right? Even if the tokenization solution is, you know, like run, like something in Opportune,
But then, okay, so here's part. It's kind of like shift the problem to MetaNet, but still MetaNet also have the, isn't that has the same issue, or
Well, it does, but I think, well,
kind of like
my
a,
hunch is that if you can solve that problem, which to me is an easier problem to solve than to have to solve it specifically for STAS and then for whoever, and then for
oh
whoever.
yeah. It's a general technique. I think if you solve one, it applies to others. So yeah, I think I haven't thought about this for the MetaNet. I think now you are like, yeah, it seems like a very similar issue. For now, for MetaNet, you also have a, almost need another server, right? I think Attila called the indexer, whatever. You need to go back to check if it's all good. And now it's a force of return. So anyway, you are doing it off chain. So it would be interesting to do, just to see whether this is doable. MetaNet, you can build a MetaNet protocol using spendable transactions. And by the way, I think you heard about the Meta ID.
Yes. Yep.
So that I think that maybe the only one MetaNet implementation, other than yours, I don't know. But they're trying to see they're exploring the same dimension to see whether you can do the MetaNet just by the miner enforced. So you don't have need a second layer. Yeah.
Yeah, I'll have to talk. I really like their spec, the Meta ID spec. I never really dug in. I didn't understand the Meta coin, but I read the Meta ID spec a while back, and I thought that was really well documented. So the problem with spendable MetaNet nodes, though, is that there's a limited supply of Satoshis, right? So I don't know. I haven't really thought through all the economic.
Just in script, right? Why is that? Does that have to do with Satoshi? You can just move the Satoshis, keep going, right? It's like a Bitcoin, right? It's
Yeah, you're right. I mean, so
you don't lock something. Yeah. You just keep.
Hopefully, we could just make transactions that are like one Satoshi that gets transferred with no mining fees or whatever else. But that isn't possible right now. So a lot of the world, I think right now, the problem right now is planning for a future that hopefully is done, but it's not happening right now. So yeah.
Okay. Yeah, for now you can always use the dust limit, and then you can keep it, and then you pay it with some. You use it, just anyone can pay, right? You can plug in new inputs just to cover the mining fee. That's how I think that's how a lot of people are doing it. I'm not sure whether it's MetaNet like a Meta ID is doing that way, but I know some people that they're doing that way. You always have a single. They keep the same dust limit, enforce it. Basically, use push DX. You said this amount is same with the regional balance. But then when you check, because even push DX, you can choose the Zcash flags, right? They use it, one can pay. So you can always cover with additional inputs just to cover the fee.
Okay, yeah, that's really smart. Yeah, that's good. Because then eventually, hopefully, that just ends up being one Satoshi, right? And then
zero.
Or zero, but I don't know about that. So we'll see.
Yeah, I think my understanding is at least based on Craig's conversation is as long as you pay any Satoshi change hand, if it's zero output, that's fine. But let's say you have two outputs, right? The first one is zero. The second one, it changed from Alice to Bob. Then that's good. If there's any, just involves any like a changing of Satoshis, then it's good. It's not saying every output has to be zero.
Okay, interesting. Yeah.
Yeah, even one is I think more than good enough. Right?
Yeah, but with just one, you run into issues if you have any large Facebook or Twitter doing that type of thing, right? So unless I don't know. But maybe zero probably is needed then. But like you said, that makes sense as long as you require some condition of Satoshi's changing hands.
Yeah. Unless you are using all zero inputs, zero outputs, then that's the issue. But if anything that changes, you can pay. That's an example he gave, right? You can have you can pay yourself, right? But just different, maybe different public key, right? You can just always pay. Then you are not even actually paying. You just change hand, right?
Yeah, that makes sense.
I was experimenting with Zoom. I just turned off because I turned off the view of myself, so I can't see myself in this meeting, which is really kind of nice to be able to focus. Because otherwise, I'm always like distracted by, you know what I mean? It's like looking in a mirror when you're trying to have a conversation. So distracting. But now I've been able to focus on just you guys, just like a normal conversation.
Okay.
Much better. There's a setting, by the way.
Okay, I haven't tried that. Okay. Yeah, from my side, is everybody's here. So
Good.
all right, I think we'll just keep it short. Anything about the sCrypt experience or push besides PushDX you want to share? Because as you said, you finally dive into sCrypt, the land of sCrypt. So I want to see.
Sorry, it took me too long. I do apologize.
No
But to be fair, I never knew C++, so I had to wait until you did something else with that anyway, and then
Oh, C++. Yeah.
or I could have learned C++, I guess, was another option, but I chose not to do that. So
Okay. Yeah, C++ is again, yeah, it's good for system programming, but most nowadays it's not popular for developing applications. I think even SDKs. I think some people ask us in the Slack channel about when are we going to have C++ SDK. We're saying okay, and where top is JavaScript, the Go, and the Python. The C++ is very rare, very rare. I think. Do we have any C++ library in BSP? I don't even remember seeing any.
I wouldn't know, I guess, but yeah.
Nakamoto, I think they have a C++ version or something. Yeah, that's the only one I remember. They have Python and I forget, C++ or Java. Yeah.
Well, I think it would be, if it's helpful, I would, I mean, I was going to do this anyway, I guess, but when we start releasing some of the stuff that we've been putting together, which a lot of it will be open source, I would like to like map, what is in sCrypt to what we have, or even just writing sCrypt contracts where we have. I think that would be really just being able to like bridge those gaps, right? Like I do think it's really valuable to learn the script language itself. I just feel like
yes, for if you are like working on the low level stuff, yes.
Because even I guess if you're trying to design something new, if you don't really understand what's going on under the hood, then you're probably not going to design it correctly. That would be my presumption, but I could be wrong, I guess.
Yeah, let me actually show this. Yeah, I think this should solve whatever the issue you just mentioned. Basically, you want to see the mapping between what the high level code is doing and what actually the under the hood, what the script is. Look, let me quickly launch this thing.
That's why I mentioned the visual
yes
website IDE. And when I still have my outline and I'm working on it, but I want to understand sCrypt better before I finish it. But when I was making an intro to sCrypt video, I actually started on that thing showing just a very simple example of the locking and unlocking script. And you just put, like Chawa did earlier, op1, op equal, and in one field, and then op1 in the other, and it unlocks. So I agree with you that it's important that people understand what's going on. But I think with the more complex things, I don't think, in the same way that if I'm writing Swift code, I don't care about what the assembly language is. But it's nice to have like a basic understanding.
Okay, can you see this?
Yep, I see.
Yes.
Yeah, so actually, if you have the premium version, once you launch the debugger from sCrypt source code, you can actually move it around. It will show you the corresponding. Can you see this mapping?
Yep.
Click each line. It will show you which part of the script it corresponds to. Let's say I click here. This is what it generates. So.
Oh wow. Okay. See, my other problem, I will admit, my other problem is I don't use Visual Studio. So even learning Visual Studio was I use Vim, so I had to like figure out how Visual Studio
works. Many years ago. But I think this is even you using Visual Studio Code, you can configure it to be like a Vim like or Emacs,
Okay.
whatever you like. So it's very, very versatile. I think that's why it doesn't judge basically. If you want use the Vim or Emacs or even Eclipse, you can configure it to be feel like exactly the same. And
That's
most,
great.
yeah, you also have extension, right? So you can. I haven't checked. Do they have this? Yeah, emulate. Yeah, you can do it anyway, and it's open source and free. So
Okay.
if you haven't
All right.
tried, yeah, if you want to push use the push TX, I think you can do the same thing here. You can just get any contract here. For example, let's say counter, right? Counter. You can let me stop this first. Yeah, this one you can stop here. You can counter. Okay. Launch it. You can also then click here, then you can see this is generated script, but of course it will be much more complex than the
Right.
optimal one because it will do a lot of it's just implement the EC design. But you can, if you go through it, you can see this is how exactly. But you have some loops, so especially when you do the addition, and because mostly because of the ending is messed up. Like sometimes it's
Right.
like a little ending, sometimes big ending, so they have to swap. So that's most of the actually the code coming from. But anyway, my point is, if you want to see a mapping, you can also use this tool. It's very good. You see this? If I click over here, it will all show you what's the generated code here. You just keep going. Yeah, that's what the mapping you want to see, right?
Yep, definitely. That makes a lot of sense.
So like this. Yeah. So if you're not, just DM me. I will send you a copy. So you
Oh,
can.
yeah, I'll grab my
Yeah,
wife.
yeah. I give it to you. That's fine. You just try this. Yeah, it's very fancy. I think
The other thing I'll just mention is that it was a little confusing since I knew I wanted the push
Push
TX.
transaction.
I had to go into like I used the CLTV script, which I know that was where your article was. Like, so then I had to, which wasn't that obviously complicated. I just had to add the maturity time or whatever. But that was the only thing I guess maybe to make push TX a little easier to like from the outside looking in was just there was nothing that just defined push TX. But I know there. What are you going to do if you know? I don't know. I guess having like a contract maybe that was just push TX that for the check sig or something, maybe that would be enough. But that's a very minor complaint. I'm just letting you know. I'm just trying to help you at all if I can.
Yes. Good feedback. Yeah, CLTV. The only reason I use it is kind of like the simplest, still like an interesting case I could think of. Because if you just put one check per unit, that's only one line. People will say, "Oh, okay, now I have it. What do I do?" So and it's kind of like a famous example, and also good to argue, right? You don't need all this, added new opcode to. You can already do it with the original one. So that's almost like a recurring thing. It's you don't need new opcode every time you want to change things. I think people, yeah, I'm not for it, but I can understand people have the urge, right? This even for the back to the Genesis, right? A lot of people, the first hunch is to let's add a new opcode or change the transaction format, right? But let's try not to. Let's try to push our limits to see. It's like Shadow said, right? Before you try to change it, see if you can do it with the existing Bitcoin. I think a lot of you can actually do.
Yeah, I mean, it has to be that we keep it the same. It has to be the same. That's what the whole thing is. It's decentralized. It stays the same. It doesn't change.
Yeah.
So everybody wants to change the code, and it's like, oh, we can't do that. So no, it's good that we're not changing it. You reminded me before we go, but you were talking about the back to Genesis thing, and I was thinking about it. Like, there's no way for me to graft like a peach onto an apple tree because they're probably different genetics, and it doesn't pick it up. but I can graft a different type of apple onto a different type of apple. And so I wonder why does it not work? Why can't you graft a peach tree onto an apple tree? And then that might help solve the problem of the bactogenesis. I'm sure that there's some sort of, or there's some sort of compatibility issue. And you might be able to figure that out. It might help. That's what I was thinking. I'll look into it more and bring back any discoveries next class.
That's really out of the box thinking. Yeah, using biology. But anyway, the Bitcoin network is also a quite good. Yeah, quantum probably hammered for a few times, biologically inspired. So it'll be that would be wonderful if anybody can use a biology kind of thing to solve this problem. That'd be very, very cool.
Yeah,
I think you're not.
Well,
far
I mean,
off,
it's just.
I think you're completely not far off at all. I think.
Yeah. Okay. Good. I don't think it's far out at all. It's I use these kinds of things all the time when I'm trying to solve computer science stuff. Go for a walk in nature and take a look.
Okay. Cool, guys. I think that's good. Almost like a follow-up to the last one. For anybody who's watching again, the push TX. And also back to Genesis. Hopefully we throw a little bit of ideas there. I think I'm keeping thinking about this, and I'm really interested if anybody or if multiple people solve it, that would be perfect. I think I've been waiting for you, and so Attila or Shadows or Brandon or whoever solve it can just educate us. That'd be good. Yeah, don't keep it secret for too long, man.
It would be very hard to, so we'll see. Yeah.
Okay. All right. Well,
all right. Just before we go, sorry, and then I'll take 2 seconds, but just to define the problem, we just want to be able to take this one branch from somewhere and verify that it's the same as the root genetics.
You're coming from,
is that right?
Certain root. Yes, you're coming from certain
root.
Without giving all the whole path, because the path can be very long.
Okay, I totally get it now.
Okay.
Yeah, because you don't want to give the entire family tree. You just want to take the thing that the little branch or the little thing that you're given now, and you want to know that it's the same as the Genesis root tree. Okay, that makes sense, because I just felt like we dove into it last time and we never really defined the problem. But now I understand what the problem is, and I can start thinking and brainstorming. I'll bring it back next time.
One more guy think about it. Okay, man. Cool. Let's see who's
from a high level, not a programming level, though.
That's fine. Yeah. Let's see who solve it first. You'll be in Bitcoin history for sure. Okay.
Great.
All right, gentlemen.
All right, you guys. Well, that was fun.
Okay. Thanks for nice talking, and hope to see you around. Okay. Have a good day.
Likewise.
Okay.
See you, Connor.
See you.
Bye.
Kevin.